Now, in this lecture, we shall study some more examples. First is presence of identical heteroatom, multiplicity of heteroatoms. When two or more heteroatoms of the same type are present in a ring, the prefixes di, tri, tetra, etc. are used and placed before the prefix used for the heteroatom. So the first example is 1,3-dioxolane. Two oxygen atoms are present, two oxygen heteroatoms are present, so we use the prefix di, oxa for oxygen and olane for 5-membered saturated heteromonocycle. The terminal letter A of oxa is dropped, so the name is 1,3-dioxolane. Another example is 1,2,4-triazole. As 3 nitrogen atoms are present, so we use the prefix tri. The next example is pyrimidine 1,3-diazine, showing 2 nitrogen atoms, so we use the prefix di. And the last is 1,3,5-triazine, showing 3 nitrogen atoms, so we use the prefix tri. Then the next is presence of different heteroatoms, order of preferences. When two or more different heteroatoms are present in the same ring, the prefixes of heteroatoms are combined in the order of their appearance in table 1. Now, table 1 I have already showed in my previous lecture. Now, in this you see the first example is thia plus aza plus ol, thiazole, 1,3-thiazole. In this, in table 1 we see that sulfur stands above nitrogen in the order of preference. So, thia, we use first thia, then aza, plus, and then ol is the stem used for the 5-membered unsaturated heteromonocycle. So, 1,3-thiazole. Similarly, oxa plus aza plus ene, oxazine, 1,4-oxazine, as oxygen stands above nitrogen in table 1 in the order of preference. And the last example is thia plus aza plus ene is equal to thiazine. Here also we see that sulfur, the prefix is thia, and nitrogen, the prefix is aza. So sulfur stands above nitrogen in table 1 in order of preference. So we use, so the name is thiazine, 1,4-thiazine. Now the next rule is numbering. With one heteroatom, the numbering in the ring starts from the heteroatom giving the position 1 and proceeds in such a way so as to give the lowest possible locant to the substituent if present. So we start with the heteroatom, numbering we start from the heteroatom, and we start in such a way that the minimum number is shown on the locant, on the substituent. Minimum lowest possible number is shown on the substituent if it is present. So the first example here is pyridine. So in pyridine, the numbering is we start from nitrogen atom, heteroatom. Then the next example is 2,5-dimethylpyridine. Again, the numbering is done in such a way that the substituent gets the lowest possible number. So 2 and 5 is the correct way, 2,5-dimethylpyridine. And the last example is 3-methoxypine. So here 3-methyl-oxoipine, 3-methyl-oxypine. So on the third position, methyl group is present. Oxa is the heteroatom prefix used for heteroatom oxygen, and ipine for 7-membered unsaturated heteromonocycle. So the name is 3-methyl-oxypine. Then with two or more identical heteroatoms. When two or more identical heteroatoms are present in a ring, the ring is numbered in such a way that the heteroatoms are assigned the lowest possible set of number locands. Now you see, first is 1 3, second is 1 4. So 1 3 is the correct numbering, 1 4 is the incorrect numbering, because lowest possible number should be on the locand. Lowest possible numbering should be on the heteroatom. Again, 1 2 4 and 1 3 4. 1 2 4 is the correct numbering, 1 3 4 is the incorrect numbering. When two or more different heteroatoms are present. When heterocyclic ring contains two or more different heteroatoms, the numbering starts from the heteroatom with the highest preference in table 1, oxygen, then sulfur, then nitrogen. Oxygen takes precedence over sulfur and sulfur over nitrogen. The remaining heteroatom are given the lowest number locands. So in this case, the first example is 1,3-thiazole. Now sulfur stands above nitrogen, so 1,3-thiazole. Similarly, 1,3-oxazole. Oxygen stands above nitrogen in the order of preference in table 1. Then 1,2-oxathiolane. Again, oxygen stands above sulfur, so 1,2-oxathiolane. 1,2,4-thiadiazole. This is the correct. 1,3,5-thiadiazole is incorrect numbering. So 1,2,4-thiadiazole, 1 is given to the sulfur atom because it lies above nitrogen in table 1, and since there are two nitrogen atoms present in the ring, so lowest possible number should be on the heteroatom. So 1 2 4 is the correct numbering, 1 3 5 is the incorrect numbering. Then we come, when a heterocyclic ring with maximum number of non-cumulative double bonds contains a saturated atom, its position is given the lowest possible locand and is numerically indicated by an italic capital H before the name of heterocyclic ring system. So here we take the example 2H14-thiazine. So here we see that on the position 2 we have the saturated atoms, so 2H14-thiazine. Sulfur stands above nitrogen, so 1,4-thiazine. Again, in the next example, 6H13-oxazine. Here also position 6 is saturated position, so and oxygen is numbered 1 as it lies above nitrogen in the table, so 6H13-oxazine. And the next is 2H-pyrrole. Now in this, second position is saturated, so the name is 2H-pyrrole. And the last is, however, the heterocyclic system in which a carbon atom of the ring is involved in the carbonyl group, the indicated hydrogen is normally cited as an italic capital H in parenthesis after the locand of the additional structural feature. So you see the first example, pyridine to 1H on. So in this we see that the second position and the keto group is present on the second position, carbonyl group is present. So 2, then italic capital H, hydrogen is normally cited as an italic capital H in parenthesis. So hydrogen on one position, so 2 1H on. Similarly, pyrazine 2 3H on. So here also we see that the carbonyl group is on position 3, hydrogen on position carbonyl group on position 2 and hydrogen on position 3. So we give the name pyrazine -2 3H in parenthesis, and then dash on. So these are the few examples. Thank you.